In this video, we are going to explain how nuclear chemistry can be a source of energy, including the worst cases that happen when using nuclear chemistry. Nuclear chemistry is mostly being used for power plants and many more. Accidents can't be avoided. One example of a nuclear accident is the Three Mile accident in County, Pennsylvania, near Harrisburg. This occurred on March 28, 1979. During the accident, one of two reactors lost its coolant, which caused overheating and partial meltdown of its uranium core. Some radioactive water and gases were released. This is the worst accident in US nuclear reactor history. The accident began with failures in the non-nuclear secondary system, followed by a stuck open pilot-operated relief valve in the primary system, which allowed large amount of nuclear reactor coolant to escape. The mechanical failures were compounded by the initial failure of plant operators to recognize the situation as a loss of coolant accident due to the inadequate training and human factors such as human-computer interaction, design oversights relating to ambiguous control room indicators in the section of power plant's user interface. In particular, a hidden indicator light led to an operator manually overriding the automatic emergency cooling system of the reactor because the operator mistakenly believed that there was too much coolant water present in the reactor, causing the steam pressure to release.
What is nuclear energy? Nuclear energy is the energy in the nucleus or core of an atom. As of today, nuclear energy is considered as one of the most environmentally friendly source of energy as it produces fewer greenhouse gases. During the production of electricity as compared to traditional sources like coal power plants. The good thing has no carbon emissions. It will remain an important clean energy resource for the future. And nuclear energy accounts for 56% of our nation's carbon-free electricity. Nuclear energy can work with renewable energy sources such as wind and solar. The electricity production from the plants can be lowered when good wind and solar resources are available and crank up when the demand is high. The benefits of nuclear energy extend far beyond carbon-free electricity too. Nuclear powers space exploration, sterilizes medical equipment, provides potable water through desalination, supplies radioscopes for cancer treatment, and much more.
There are many applications of radiochemistry industry such as power plants and engineering. Nuclear power plant technology produces materials that are active in emitting radiation and are therefore called radioactive. When determining the thickness of metal, radioactive emissions are utilized to penetrate the metal. Also, when determining the flow of a pipeline or finding leaks, a radioactive substance is injected into the pipe and monitored. Radioisotopes, nuclear power process, heat, and non-stationary power reactors have essential uses across multiple sectors, including consumer products, food and agriculture, industry, medicine, and scientific research, transport, and water resources in the environment. It is also used in industrial tracers. Radioisotopes are used by manufacturers as tracers to monitor fluid flow and filtration, detect leaks, and gauge engine wear and corrosion of process equipment. Small concentrations of short-lived isotopes can be detected while no residue remain in the environment. By adding small amounts of radioactive substances to materials used in various processes, it is possible to study the mixing and flow rates of a wide range of materials, including liquids, powders, and gases. Radioactive materials are used to inspect metal parts and the integrity of welds across a range of industries. For example, new oil and gas pipeline systems are checked by placing the radioactive gauges containing radioactive, which is usually gamma sources, are in wide use in all industries where level of gases, liquids, and solids must be checked. They measure the which has been absorbed in a given materials.
In the early morning hours of April 26, 1986, the Chernobyl nuclear power plant in Ukraine exploded, creating what many consider the worst nuclear disaster the world has ever seen. The Chernobyl nuclear power plant is located about 81 miles north of the city of Kiev, Ukraine. It is made up of 4 reactors that were designed and built during the 1970s and 1980s. A man-made reservoir, roughly 8.5 square miles in size and fed by the Pripyat River, was created to provide cooling water for the reactor. According to the World Nuclear Association, the Chernobyl plant used 4 Soviet-designed RBMK-1000 nuclear reactors, a design that's now universally recognized as inherently flawed. RBMK reactors were of a pressure tube design that used an enriched uranium dioxide fuel to heat water, creating steam that drives the reactor's turbines and generates electricity. In most nuclear reactors, water is also used as a coolant and to moderate the reactivity of the nuclear core by removing the excess heat and steam. But the RBMK-1000 used graphite to moderate the core's reactivity. The explosions killed 2 plant workers, the first of several workers to die within hours of the accident. For the next several days, as emergency crews tried desperately to contain the fires and radiation leaks, the death toll climbed as plant workers were exposed to acute radiation sickness. 28 of the workers at Chernobyl died in the first 4 months following the accident, including some heroic workers who knew they were exposing themselves to deadly levels of radiation in order to secure the facility from further radiation leaks. While there may still be additional causes of cancer that emergency workers, evacuees, and residents may experience throughout their lifetimes, the known overall rate of cancer deaths and other health effects directly related to Chernobyl's radiation leak is lower than was initially feared. Shortly after the radiation leaks from Chernobyl occurred, the trees in the woodlands surrounding the plant were killed by high levels of radiation. This region came to be known as the Red Forest because the dead trees turned a bright ginger color. Today, it is filled with a variety of wildlife that have thrived without interference from humans. It is currently composed of wolves, deer, lynx, beaver, eagles, boar, elk, bears, and other animals have been documented in the dense woodlands that now surround the silent power plant. Nonetheless, a handful of radiation effects, such as stunted trees growing in the zone of highest radiation and animals with high levels of cesium in their bodies, are known to occur.